Hello everyone, welcome to Cyber Platter. This is a video on IC Square CCSP to help you prepare for the certification. Today we will review Domain 5, that is Cloud Security Operations. Basic Input-Output System BIOS tests hardware and loads the operating system from disk when a computer boots. BIOS is stored on firmware chips instead of on disk. Unified Extensible Firmware Interface UEFI, successor of BIOS, backwards compatible with legacy BIOS functionality and security. UEFI may be built upon a specialized hardware chip known as the Trusted Platform Module (TPM), verifies firmware before loading to confirm its integrity. Secure boot feature of UEFI. UEFI has a secure boot feature that checks to see that the firmware is valid and intact before allowing it to load. It does this by either computing a checksum of the firmware and comparing it to a list of approved checksums, or by verifying a digital signature applied to the firmware by the device manufacturer. If an attacker attempts to insert malware into the firmware, UEFI would block it from loading because the signature is not intact. Trusted Platform Module (TPM), a cryptographic chip used for device security. The chip is physically secure to make it tamper-resistant and logically secure to protect against software interfering with its security functions. By being hardware-based and physically secure, the TPM can help protect against compromised operating systems, privileged account misuse, and other software-based vulnerabilities. UEFI's root of trust is TPM. Virtual TPM (VTPM), provided by the hypervisor and brings the security goodness of physical TPMs to virtual machines and guest operating systems. Verifies hypervisor integrity. VTPMs rely on the hypervisor to provide an isolated environment that is segregated from the actual virtual machines in order to secure the TPM code from the VM's OS and applications. Common security-related functions of TPM. Platform integrity. When a platform is powered on, the TPM validates that a trusted combination of hardware and software is in place before fully booting the OS. A UEFI uses this feature, which is considered establishing a root of trust. Drive encryption. When encrypting a drive or disk, you can seal the encryption keys within a TPM. Doing so ensures that the drive cannot be decrypted unless the operating system has securely booted into a known good state. Password protection. Passwords are protected from attacks like dictionary attacks and allow more secure authentication. Hardware Security Module (HSM), a physical computing device that provides crypto processing and safeguards and manages digital keys for strong authentication. HSM manages, generates, and stores crypto keys. Review of HSMs is done by an independent lab. Storage Controller, a device that manages and controls storage arrays. Controller-based encryption. Consider vendor recommendations. May be in use for iSCSI, fiber channel, or fiber channel over Ethernet. Network Controller, a centralized point of control used to configure, manage, and monitor a physical and virtual network infrastructure. Securing servers. Secure build. Follow OS vendor recommendations. Secure initial configuration. Consider business or regulatory requirements, risk assessment, risk appetite, system workloads, OS vendor, operating environment, etc. Host hardening. Remove all unwanted services and software. Host patching. BIOS or firmware updates, driver updates for specific hardware components, OS security patches. Host lockdown. Restrict root or admin access. Use host-based firewalls. Use RBAC role-based access control permissions. Use only secure communications like SSH. Secure management practices, ongoing patching and maintenance, periodic vulnerability scanning, periodic penetration testing. Network security includes virtual firewalls, network IDS, IPS logging systems. Storage security includes MFA, disable unnecessary protocols and APIs, logging and monitoring, strong credentials. Firewalls. Firewalls are the primary network security control used to separate networks of differing security levels. Mostly, firewall uses three zones: trusted intranet, untrusted internet, DMZ that houses publicly accessible servers. A few operating system security principles to keep in mind when managing security of a system: disable unnecessary services and applications, close unneeded network ports, disable default accounts and passwords, apply all security patches. Under provisioned services exist when demand exceeds capacity. In such cases, services should be upsized to meet changing demand. Over-provisioned services exist when capacity exceeds demand. Those services should be downsized to reduce costs. Automated alerts notify administrators of monitoring irregularities. Multi-tenancy complicates performance and capacity monitoring in the cloud. Customers have access to resource monitoring and should pay particular attention to CPU utilization, memory utilization, network bandwidth consumption, response time. Defense in depth. Organizations should use a variety of overlapping security controls to prevent against the failure of a single control. When designing overlapping controls, strive for diversity of vendors and control types. Virtualization management tools. All management should take place on an isolated network. Defense in depth, access control, log sufficient data, auditing and monitoring, maintenance. Secure configuration templates should be used to configure virtualization hardware. Templates should be saved in a secure manner. Update templates via formal change management process. The virtualization platform determines what management tools need to be installed on the host. Plan to maintain and update the tools. Plan for maintenance windows and VM migrations between hosts to allow for updates and reports. Perform vulnerability testing on the tools. Follow vendor guidance for securely configuring toolsets. Physical access should be limited. Individuals who manage physical hardware should not have other types of administrative access, that is, separation of duties. Virtualization security configuration. Manage system resources for efficiency and sufficiency. Manage virtualized hardware, CPU cycles, memory capacity, storage capacity, network bandwidth. Patch and manage guest operating systems the same way you would in a traditional environment. Secure hypervisor. Monitor hypervisor updates, apply hypervisor updates, maintain awareness of added complexity. Maintain separation of security zones even when traffic doesn't touch the network. Leverage virtualization platform management tools. Virtualization toolkits improve interaction between the hypervisor and guest. Common secure local and remote access mechanisms. Keyboard video mouse KVM, console based access, remote desktop protocol RDP, secure KVM. KVM solutions provide keyboard, video, and mouse service to many servers located in a data center from a single physical or virtual location. Provides secure access and prevent data loss. Access to KVM should be logged and audited regularly. Consider MFA for KVM access. Secure KVM traits. Isolated data channels, secure data ports. Tamper warning labels on each side of the KVM. Housing intrusion detection. Fixed firmware. Tamper proof circuit board. Safe buffer design. Selective Universal Serial Bus USB access, push button control, air gapped push button, console based access. Regardless of vendor platform, all VM management software offers a manage by console option. The use of these consoles to access, configure, and manage VMs offers an administrator the opportunity to easily control almost every aspect of the VM's configuration and usage. Administrators may access Windows systems using the Remote Desktop Protocol (RDP), which runs on TCP port 3389. RDP is considered an insecure protocol and should only be used within closed or private networks. Do not expose RDP over the internet without VPN protection at a minimum. Linux systems may be accessed using the Secure Shell (SSH) protocol on TCP port 22. Virtual LAN (VLAN) allows us to logically group together related systems regardless of where they exist on the physical network. VLAN communication. Virtual LANs extend the broadcast domain. That means users on the same VLAN will be able to directly contact each other as if they were connected to the same switch. Configure VLAN. Enable VLAN trunking. Assign switch ports to VLANs. VLAN-related security. Enable VLAN pruning. Disable unnecessary protocols on switches. Simply powering off a virtual machine still leaves the image file susceptible to malware infections and missed patches. Load balancers. Distribute connection requests among many identical servers. Virtualized clusters increase the flexibility of high availability approaches. VMware uses distributed resource scheduling to allow the balancing of capacity across devices. TLS to be used to secure network communications. SSL is no longer secure. Network discovery scanning uses tools like NMAP to check for active systems and open ports. Network vulnerability scanning first discovers active services on the network and then probes those services for known vulnerabilities. Web application vulnerability scans use tools that specialize in probing for web application weaknesses. The vulnerability management workflow includes three basic steps: detection, remediation, and validation. Penetration testing goes beyond vulnerability scanning and attempts to exploit vulnerabilities. Transport layer security (TLS). TLS record protocol provides the actual secure communications method for data in transit, ensures data confidentiality by encrypting the connection with symmetric key encryption, and validates data integrity using hashes and checksums. TLS handshake protocol allows two parties like a client and server to authenticate each other and negotiate the parameters of the TLS connection, including the session ID and encryption algorithms to be used. The entire handshake process occurs before any secure data is transmitted. DNS, a hierarchical and decentralized naming system, allows to use user-friendly names instead of IP addresses, operates over UDP port 53. DNSSEC, security extension to DNS, provides origin authority, data integrity, and authenticated denial of existence, does not provide confidentiality. DNSSEC uses a process called zone signing, which uses digital certificates to sign DNS records. Helps against farming attacks, fake website credential harvesting, volume based attacks, DNS poisoning. Threats to the DNS infrastructure. Footprinting. An attacker attempts to gather DNS zone data for a domain via zone transfer in order to map out the target environment like DNS domain names, computer names, and IP addresses. Denial of service attack. When an attacker attempts to deny the availability of network services by flooding one or more DNS servers in the network with queries. Redirection. When an attacker can redirect queries for DNS names to servers that are under the control of the attacker. Data modification. An attempt by an attacker to spoof valid IP addresses in IP packets that the attacker has created. This gives these packets the appearance of coming from a valid IP address in the network. With a valid IP address, the attacker can gain access to the network and destroy data or conduct other attacks. Spoofing. When a DNS server accepts and uses incorrect information from a host that has no authority giving that information. DNS spoofing is in fact malicious cache poisoning, where forged data is placed in the cache of the name servers. VPNs provide two important network security functions to IT administrators. Site to site VPN allows the secure interconnection of remote networks, such as connecting branch offices to a corporate headquarters or each other. Remote access VPN provides mobile workers with a mechanism to securely connect from remote locations back to the organization's network. Most common VPN protocols: IPsec, Internet Protocol Security, commonly used for site-to-site VPN, difficult to configure. TLS, Transport Layer Security, commonly used for remote access VPNs, easier to configure. VPN types: full tunnel VPN. Any traffic leaving the remote device is sent through the VPN back to the home network unprotected by encryption. Split tunnel VPN. Some traffic is sent through the VPN while other traffic is sent out through the user's local network. The routing policy is set by the VPN administrator, provides a false sense of security. IPsec protects communication over IP networks, supports network level peer authentication, data origin authentication, data integrity, encryption, and replay protection. There is a performance impact when using IPsec for data encryption. IPsec uses authentication headers AH to provide authentication, integrity, and non-repudiation. It uses encapsulating security payload ESP to provide confidentiality. IPsec modes. Tunnel encrypts the entire original packet and provides a new header, supports NAT traversal. Transport only encrypts part of the original package. DHCP, Dynamic Host Configuration Protocol, configure a pool of IP addresses and then automatically assign those addresses to systems as they join the network. DHCP, Dynamic Host Configuration Protocol, configures a pool of IP addresses and then automatically assigns those addresses to systems as they join the network. OS hardening with baselines. Minimum requirements. Configuration management tools such as Puppet and Chef can ensure operating systems are hardened according to a given baseline or policy. Monitor hosts for baseline compliance and remediate anything out of compliance. Deviations from the baseline should be investigated and documented. Documentation is very important in order to get full benefit of system baseline. Always keep secure copy of secure system baseline. Baseline should be configured as per vendor recommendations. Sources of security baselines. Vendors, example Microsoft Security Compliance Toolkit. Government agencies, example NIST. Independent organizations, example CIS, Center of Internet Security. Customizing security baselines, scope and tailor standards to meet organization specific requirements. Standalone hosts. Business requirements may dictate the need for standalone hosts in a cloud environment. Standalone host advantages: isolation, dedicated host, more secure. Standalone host disadvantages: lack of clustering benefits, higher costs, lack of elasticity. Driving factor for use of standalone hosts: regulatory issues, security policies, contractual requirements, application or business process, data classification, performance. Clustered hosts, a group of centrally managed servers that allows for failover and VM migration between hosts, provides high availability. Clustered hosts resource sharing utilizes reservations, limits, shares. Clusters use distributed resource scheduling (DRS). A resource manager uses rules to balance the workload. Affinity rules can be used to keep VMs on the same host. Anti-affinity rules keep VMs on separate hosts. Distributed resource scheduling (DRS). used within all clustered systems as a method for providing high availability, scaling, management, workload distribution, and the balancing of jobs and processes. Dynamic operation (DO), basis of auto scaling and rapid elasticity, allow the automated shifting of workloads. It ensures that resources are available when and where needed and that physical nodes do not become overloaded or near capacity while others are underutilized. Storage cluster goals meet SLAs, customer data isolation, secure storage, clustered storage architecture, tightly coupled cluster, loosely coupled cluster. Tightly coupled cluster. All the storage devices are directly connected to a shared physical backplane, thus connecting all of them directly. Each component of the cluster is aware of the others and subscribes to the same policies and rule sets. A tightly coupled cluster is usually confined to more restrictive design parameters, enhances performance as it scales. Loosely coupled cluster allows for greater flexibility. They are only logically connected and don't share the same proximate physical framework, so they are only distant physically connected through communication medium. Performance does not necessarily scale. Maintenance mode allows taking hardware out of a virtualization pool temporarily when it is repaired. All operational instances are removed from the system or device before entering maintenance mode. Prevent all new logins. Ensure logging is continued and begin enhanced login. Remote access solution key features. Session control, access approval, session duration limits, idle timeouts. Accountability, log and audit trail. Real-time monitoring, isolation, secure access, encryption, MFA, OS baseline compliance monitoring and remediation, miss to apply baseline, unauthorized modification by an admin, unauthorized modification by a malicious outsider, missed policy exception. Patch management, a subset of configuration management that includes all processes for finding, testing, and applying software patches to products, applications, and systems. Correct security and functionality problems. Patching in a cloud environment is typically performed by re-imaging hosts from the new. NIST SP 840 Guide to Enterprise Patch Management. Patch management process. Identify that a required patch exists. Acquire the patch. Test. Use hashes to verify patch integrity. Patch in a development environment. Deploy the patch to production. Validate that the patch is applied properly and everything is working correctly. Patch management addresses, vulnerability detection, vendor patch notification, sign up, patch severity assessment by the organization, change management, customer notification if needed, verification of successful patching, risk management in case of unexpected outcomes after applying patches, rollback plan. Patch management challenges, lack of standardization of patches, collaboration between multiple system owners, complexity, many moving parts, testing patches, multiple time zones, VM in a suspended state is not patched. Patch management. In some cases, organizations may give blanket approval for applying patches which addresses imminent risks, allowing these patches to bypass standard change management process. Change management will take place after the fact. Monitoring performance and capacity is critical. Changes in performance can indicate failing hardware. Unmonitored capacity could allow for total consumption of resources, which can lead to resource starvation and a serious impact on performance. What to monitor on host hardware? Excessive dropped packets on network interfaces, CPU utilization, disk capacity and I/O, memory utilization, hardware monitoring, environmental temperatures, temperature within hardware, fan speeds, failed drives or drive errors, hardware components, CPU, memory cards, network devices, not just servers. Backup and restore. Host configuration data should be included in backup plans. Routine tests should be conducted to test the restorability of backup data, individual file recovery, entire VM image recovery. Routine tests increase the likelihood of a successful BCDR failover. Backup and restore challenges. The extent to which we have access to the host and what configurations can be changed. Control. Confidence that changes we make are the only changes occurring. Visibility. Ability to monitor data and how it is being accessed. Virtual machine introspection allows for agentless retrieval of the guest OS states such as the list of running processes, active networking connections, and open files. VMI can be used to perform external monitoring of the VM by security applications such as an IDS or an IPS. This monitoring is widely used for malware analysis, memory forensics, and process monitoring. Management plane helps manage hardware through baseline configurations, logical assets, task scheduling, resource allocation, software updates, networking, network management, routes, access lists, security groups, virtual switches, VLANs. Management plane actions, scheduling of resources through distributed resource scheduling (DRS), orchestration or automation of changes and provisioning, maintenance such as software updates and patching. ISO 27001 Information Security Management, Security Management, Security Policy, Information Security Organization, Asset Management, Human Resources Security, Physical and Environmental Security, Communications and Operation Security, Access Control, Information Systems Acquisition, Development and Maintenance, Provider and Customer Responsibilities. Configuration Management, tracking and controlling configuration changes to systems and software. Change management, review, approve, and document any modifications to the environment. Configuration or change management objectives. Respond to a customer's changing business requirements. Respond to business and IT requests for change. Ensure that changes are recorded and evaluated. Ensure that authorized changes are prioritized, planned, tested, implemented, documented, and reviewed in a controlled manner. Ensure that all changes to configuration items are recorded in the configuration management system. Optimize overall business risk. When is configuration or change management required? Buying, building, or deploying new hardware or software, upgrading or modifying existing hardware or software, decommissioning hardware or software, modifying the operating environment, modifying IT documentation. Configuration or change management roles and processes. Configuration or change management board responsible for reviewing and approving change and exception requests. The process, documentation requirements, instructions for requesting exceptions, assignment of change management tasks, procedures for addressing deviations, enforcement measure and responsibility. Configuration or change management forms. Initial baseline effort occurs once, normal operation mode repetitive. Configuration or change management process for baselines. Full asset inventory, codification of the baseline, secure baseline build, deployment of new assets. Configuration or change management process for normal operations. Request a change, evaluate the requested change, that is done by Change Advisory Board, CAB. Approve the change, again it is done by CAB. Plan the change, implement the change, review the change. Incident management. Process of monitoring for, responding to, and minimizing the impact of incidents. An incident is any event that can lead to a disruption in a service provider's ability to provide its services to users or customers. Incident management goal: minimizing the loss of value or assets, continuing service provision, availability, halting increase of the damage. Incident management objectives ensure that standardized methods and procedures are used for efficient and prompt response analysis, documentation of ongoing management, and reporting of incidents. Increase visibility and communication of incidents to business and IT support staff. Enhance business perception of IT by using a professional approach in quickly resolving and communicating incidents when they occur. Align incident management activities with those of the business. Maintain user satisfaction. What should an incident management plan include? Definitions of an incident by service type or offering, customer and provider roles and responsibilities for an incident management process from detection to resolution, response requirements, media coordination, legal and regulatory requirements such as data breach notification. Incident classification, impact, effect upon the business, urgency, extent to which the resolution can bear delay, priority, impact into urgency. Incident response process, detection, response, mitigation, reporting, recovery, remediation, lessons learned. Problem management. Minimize the impact of problems on the organization by identifying the root cause of the problem. A problem is the unknown cause of one or more incidents, often identified as a result of multiple similar incidents. A known error is an identified root cause of a problem. A workaround is a temporary way of overcoming technical difficulties, incidents, or problems. Release and deployment management. Plan, schedule, and control the movement of releases to test and live environments. The primary goal is to protect the integrity of the live environment. Service level management. Service level agreements, SLAs, negotiated with the customers. Operational level agreements, OLA, SLAs negotiated between internal business units within the enterprise. Underpinning contracts, UC, external contracts negotiated between the organization and vendors or suppliers. Availability management. Define, analyze, plan, measure, and improve all aspects of the availability of IT services. Capacity management, a process of ensuring that the required resource capacity exists to meet or exceed business and customer needs as defined in SLAs. Continuity management helps ensure that a cloud service provider is able to recover and continue providing service to its customers even amidst security incidents or during the times of crisis. Involves conducting a business impact analysis BIA to prioritize resources, evaluating the threats and risks to each of those resources, identifying mitigating controls for each risk, and developing a contingency plan that outlines how to address potential scenarios. Digital forensics, a branch of forensic science that deals with the recovery, preservation, and analysis of digital evidence associated with cyber crimes and computer incidents. Cloud forensics challenges. Customers' control over data depends on the service model. Seizing servers that may contain multiple tenants' data creates a privacy issue. Trustworthiness of evidence is based on the cloud service provider. Investigations rely on the cooperation of the cloud service provider. Cloud service provider technicians collecting data may not follow forensically sound practices. Data may be in unknown locations, conflicting international laws. Forensics readiness, backups, audits, file integrity checks, baselines, data retention policies. Forensics data collection process, collection of evidence, identification, labeling, recording, preservation of data integrity, examination, processing evidence, extracting data while preserving data integrity, analysis, deriving useful information from evidence, reporting on findings, including tools and procedures used, recommendations, and alternate explanations. Data acquisition and collection. Develop a plan to acquire the data. Likely value of data, volatility of data, amount of effort required to acquire different data sources. Acquire the data. Verify the integrity of the data. Examining the data. Bypass features that obscure data such as encryption. Use text and pattern search to look for evidence. Tools to inventory or categorize files. Knowledge of data file types. Using databases containing information about known files. Analyzing the data. Identifying people, places, items, and events and determining how these elements are related so that a conclusion can be reached. Comparing system characteristics to known baselines can identify various types of changes made to the system. Reporting the findings. Alternative explanations. Be prepared to support all possible explanations. Audience consideration. Law enforcement involvement requires highly detailed reports. A system administrator might want to see network traffic and related statistics. Senior management might simply want a high level overview of what happened. Identifying actionable information gained from data that may allow you to collect new resources of information. Some relevant standards: ISO IEC 27037 Guide for Collecting, Identifying and Preserving Electronic Evidence. ISO IEC 27041 Guide for Incident Investigations. ISO IEC 27042 Guide for Digital Evidence Analysis. ISO IEC 27043 Incident Investigation Principles and Processes. ISO IEC 27050 Overview and Principles for E-Discovery. Network forensics. Capture, storage, and analysis of network events. Use cases: uncovering proof of an attack, troubleshooting performance issues, monitoring activity for compliance with policies, sourcing data leaks, creating audit trails for business transactions. Chain of custody. Used to track and manage evidence from identification to disposal. Provides non-repudiation. Evidence management. Be sure not to collect evidence outside the scope of the event. Never work from the original data, always work from a copy. Chain of custody is required when evidence is gathered, when evidence is stored, when evidence is removed from storage, when evidence is transported, when any action is taken, when evidence is analyzed. Communication with relevant parties. Who is the target of the communication? What is the communication designed to achieve? When is the communication best delivered or most likely to reach its intended target? Where is the communication pathway best managed from? Why is the communication being initiated in the first place? How is the communication being transmitted and how is it being received? Vendor and partner communications. Establish communication path. Identify and document all partners and vendors. Role and criticality of the partners and vendors. Partners and vendors access. Emergency communication protocols. Key contacts. Clearly defined onboarding, management, and offboarding processes. Supply chain vendor categories. We have strategic, operational, tactical, and commodity suppliers. You can see in this picture how strategic and all the other suppliers are rated. Strategic suppliers are of high risk and high value. Okay. Strategic suppliers. Mission critical and cannot be easily replaced if they become unavailable. Most crucial to the success of the enterprise cloud architecture. Systematic, long term, and holistic approach. High risk, high cost impacts. Tactical suppliers. Supplement strategic and commodity suppliers to manage emerging unforeseen issues and incidents. Short term transactional activity commonly practiced in small to medium sized manufacturing organizations. Focuses on processes and procedures that can save time and money while also meeting customer demands and providing value. mid-risk, mid-cost or impact. Operational suppliers deals with meeting the daily purchasing needs of organization. Low risk, mid to high cost or impact, or mid or high risk, low cost or impact. Commodity suppliers provide goods and services that can easily be replaced and sourced from a variety of suppliers if necessary. Low risk, low cost or impact. Customer communications, internal and external customers. Know your customers. Different customers use services differently. Identify individual responsibilities and document them in SLAs. Regulators communications. Early communication is the key. Requirements based on geography, jurisdiction, business type, example medical or finance, services offered, example processing credit cards or personal data, data types, example classification, sensitivity. Understand all the requirements and expectations of compliance. Security Operations Center serves as the first point of contact for all cybersecurity activities, a central point for the monitoring of security controls. Monitoring security controls, firewalls, intrusion detection systems, intrusion prevention systems, honeypots, vulnerability assessment tools, network security groups, SIEM, system logs, endpoint security controls. Security information and event management goals, aggregation of data from many sources, correlation, identify and connect common attributes amongst separate data sources in order to provide useful information, alerting, dashboards, single graphical view of multiple alerts and data points, forensic analysis. If system logs are wiped by attackers, SIEM will keep a safe copy of the system logs. Security Operations Center SOC monitor environment for abnormal behavior and signs of compromise, analyze system logs, protect the organization from attacks, perform vulnerability scans, monitor internet traffic and other traffic flows, handle asset discovery and management, assist with incident response. Log capture and analysis, event sources, host servers, guest operating systems, network devices, centralized and offset storage of log data. Log injection attack. A log injection attack occurs when an attacker creates false log entries or injects malicious content into logs through unvalidated inputs. Perform sanitization on all event data to prevent log injection attacks. Log collection, input validation, sanitization, data format. If writing to database, make sure it is not susceptible to SQL injection. Make sure logging failures do not affect the application. Time synchronization, logging verification. Ensure the logging is working correctly. Events classification is consistent. Make sure it is not susceptible to log injection attacks. Make sure no side effects. Check the effect on the logging mechanisms when external network connectivity is lost. Ensure that logging cannot be used to deplete system resources. Test the effect of logging failures on the application. Proper access controls on the event log data. If log data is utilized in any action against users like blocking access or account lockout, ensure that it cannot be used to cause denial of service of the other users. This completes the review of domain 5. I'll see you in the next video. Thank you so much for watching. Bye bye.